What's going on, everybody? Core here at CDS. Today, I wanted to bring you along, kind of run through my diagnosis on a 2011 Kia Sedona, and the customer had stated that the transmission was not shifting properly. They also had a scan tool or a code reader and were able to retrieve a P0880 out of the powertrain system. So, talking with this customer, they had just recently purchased the vehicle, so we had no prior history or maintenance records or anything on this vehicle. They brought it to us. The vehicle is very clean, and we went in and scanned and in fact found a P0880. Now, when this P0880 sets on this vehicle, it will default to fourth gear failsafe. Basically a limp mode, and it fails safe. It'll be locked into fourth gear. So you'd shift it into drive. It would be a harsh engagement. He had reverse, obviously stuck in fourth gear due to the failsafe mode. The thing would take a little bit to get up and rolling, and then it seemed to plane out okay for a little while you drove it. But interestingly enough, what I found, we'll just run over the background here. So the general description is that the PCM-TCM monitored supplied voltage, the ATM solenoid valve, and if it's not within a specified range, fourth gear is fixed. So that would be our limp mode. And then you look at the possible causes. You can see up top there's the DTC number, kind of description operation through Kia, and then possible causes. They're saying a circuit issue, either an open or a short, or the PCM TCM. So that was our job, to discern what was what and figure out what was going on to get a diagnosis and a repair done for this gentleman. So you can see here, this is also under there. It's just a quick shot of the diagram. So basically there's one power supply for there's 8 solenoids in total, and there's one main power feed for 4 of the solenoids, and then another power feed for the other 4 of the solenoids. So what I had initially done was hooked up the scope, and obviously if you've dealt with this before, you know that that connector is the only thing you see coming up out of the transmission. This is the internal harness part of it. There's another sub harness that goes right here for the speed sensors, but for our all intensive purposes, for what we're looking at, all those connectors, those 2 prongs on each of those, that all clips into a solenoid. So what I had done is we obviously checked, power and control to the solenoid to ensure that the PCM and our wiring were intact, and we found that to be intact. So I knew at that point then our issue is internal to the transmission, but deciphering where and what the issue is was our next task. I got this pulled up just so you can kind of see. Those are all your shift solenoids, and this lead frame, or this internal harness, clips right across here, kind of lays over, and that's what clips into these solenoids. So all those guys would be clipped onto here, and then this comes up and wraps up and bolts inside in the case. I'm sorry, actually to the front of the valve body, and then that connector is what comes up and through, and that's all you see when it's installed in the vehicle. And what I had found is I had gone through and tried to control each one of these solenoids individually. So I had applied power to our one wire or one bank, right? So we'd hook in there, constant power, and then I would ground the solenoid and look for a current flow. I had an amp clamp around each one, and I just recorded the results. And I only had 2 of the solenoids with a circuit that was intact and was able to flow current. So I knew at that point the only way to pinpoint this the rest of the way out was to remove the valve body. And in this case, the valve body is kind of intertwined with this. You can't just pull the harness out without removing the valve body. But that was good for us because I wanted to bench test each one of those solenoids anyways and ensure that it wasn't bound up. It wasn't shorted or anything like that, because remember, if looking back at our possible causes, circuit open or short. Well, we know that the PCM can control it, and we know that our circuit is intact up to this point, so that leaves us with this harness or the solenoids. And the fact that there was 5 solenoids in here, there's a total of 8, there was 5 in here that wouldn't flow any current. It was open circuit. So, you know, the odds of 5 solenoids failing all at the same time, this customer said that it was fine for 4 or 5 days after they had purchased it. Then all of a sudden they just said there was a lack of power and didn't really want to seem to move. And that was due to our 4th gear failsafe, or our locked into 4th gear. So I had gotten this, I got the valve body out, and I got the lead frame out, or the harness out, and I was testing my solenoids, and they were good across the board. They were all flowing the same, relatively close to the same amount of current. I didn't see any indication on the waveform that they were shorted, and I actually slid them out of the valve body and checked the screens, and there was no debris, there was no clutch material, there was no metal, there was no sludge. Everything was looking very, very good. For the age and the mileage on the vehicle, everything was looking great. So that brings us back to our lead frame, or our harness, whatever you want to call it. And what I had found is, and this isn't the first Kia that I've ran into with this, but I think this technique could maybe save you a couple of minutes, or, you know, really verify the problem without just guessing and putting parts in, because we don't want to guess and just start replacing parts on a whim. So what I had done is, each set of those goes to a solenoid, right? But each one of those has a track on this ribbon cable and comes back to a corresponding pin. I'll move that one. The large pin, see there, oh, let that focus. The yellow lead is on one of our main power lines coming in, and the other one to the right underneath the blue pin, is the other power wire. So one is that one, and one is that one. So what I did is I had substituted a known good resistance value, which in this case is 2.8 ohms of a fixed resistor, and I just went across each one of these to see what my resistance value was here. I wasn't necessarily concerned about the ability to flow current at this point, which is usually what you want to look for, but in this case, I knew that we had a complete open, or very close to an open, so I was confident that when we got to our problem solenoid connectors, we'll say, on this bar, that it was going to be apparent. So again, that's just knowing what you're looking for, what you're expecting to see in the circuitry, and what I had found with the prior testing with this harness still in the vehicle. So I knew what I was going after. It was just pinpointing down where exactly it was. The fact that the solenoids load tested fine and were functioning, that leaves us with this. That's the only other piece. So interestingly enough, like I said, I checked resistance, which I'm always not a huge proponent for. So that is 59,000 ohms, and obviously it's bouncing. But what I had found, and I've seen this on several of these Kia harnesses, so if you're not familiar with this, it's a problem area. I'm not saying just go in and replace it, but it is a problem area in the circuit. If we just move this, and imagine just this bouncing in the vehicle. I'm just flexing on that ribbon cable just a little bit, and it's open circuit. Not changing anything out here. Everything is still, our pins are still on correctly. Just moving. Yeah, we might have just lost it for good. Oh, no. So that's the importance of this, because these wiring harnesses are relatively inexpensive in comparison to transaxle replacement as a whole unit. And if a shop said, well, we're going to put a transmission in it, if you had a good harness in there, yeah, you would have corrected that pin fitment tension issue. But again, with the age of the vehicle and the mileage and the fact that the customer just bought it, they were not anticipating on putting a transmission into it. So we were able to save them a lot of money by just root cause analysis going in. Teardown was necessary, but we made sure that we had explained to the customer exactly why we were going in and what we were going in for. We weren't just tearing it apart for the sake of tearing stuff apart to take a look. Like, we knew we had electrical circuit issues and that it was likely to be in the wiring harness, but until we got the valve body on the bench, we weren't sure. So basically, when I had this out, I just put a lead power ground on each solenoid and measured the current flow and wrote down the results for all that. So we knew that when we put it back together, that all these solenoids were free of debris and they were moving properly, and then relatively speaking compared to each other. There's a few different part numbers in there, so they didn't all read the exact same, but the same group, the same part numbers were relative to each other, indicating that our issue was not in the solenoids themselves, and it was not in the mechanical portion of the valve body with the balls and the springs. So, electrical issue, again, I just want to iterate the importance of developing a test plan suitable for the problem at hand, and that, knowing what the customer was experiencing, the customer says it doesn't move very quickly. Okay, well, it's in fail-safe, so it's not going to move very quickly in fourth gear. What are our causes? What's our trouble code? And again, a trouble code is not a part number for something to replace. It's very important. So verifying that everything was load tested present to the transmission is crucial. And then verifying just with a little bit of tear down, get the valve body out, get this harness out, bench it, get it to a point where we can test it, substitute a known good value. Again, with the open circuit, I wasn't concerned about running a bunch of high current flow through this harness, just based on what I had seen with it still installed in the vehicle. So I knew just with this test was adequate. And it's not like you're going to go in and repair. I'll pull these out here. I wasn't going to go in and disassemble and repair this. I think it's a pretty poor design, to be honest with you, but somebody at Kia deemed it feasible, and well, it's in production anyway. So I thought you guys might find that interesting. Thanks for watching. If you run into this, just be mindful of moving the harness can alter your readings. So if an issue comes and goes, just move with purpose through your testing and have a test plan, know what to expect, where you're testing, and let the results drive you to the next test. So guys, thanks for watching. Have a great day.